States and the principal and founder of AdCom Engineering. Prior to starting AdCom in 1979, he worked for Motorola in a small telephone equipment manufacturer. Joe's been engineering and installing Simulcast systems since the early 70s, believe it or not. AdCom Engineering has worked on over 500 communications projects, ranging from low-band paging systems to 900 megahertz trunk systems. Joe has freely shared his expertise at the Simulcast Forum for the last 15 years, and we do appreciate it. Joe is going to give us an overview of 3 of the projects that AdCom recently completed. I'd like to welcome Joe this morning.
First part of doing is figuring out how to use it. Cool. Well, actually, it was good to hear that the story about analog staying around for a long time. We've kind of gone to some of this advanced technology and went to P25, found out, well, maybe that wasn't the best thing. So that's all good. I'm hanging on to my 829s, 829Bs, and my 6146 tubes, because this solid state stuff isn't going to last. And those two things on my shelf, I'm going to use them one of these days, right? So, when I first started AdCom Engineering a long time ago, I had another guy that worked for me who's sort of gone to the great antenna in the sky now, but he always told me, too old we get too fast, too smart we get too slow. And that was, these 3 project recaps are going to be a little bit of a discussion of some of those lessons that sometimes we know, but we have to relearn to get this works right. There you go, so hopefully that's actually the first one. Okay, so we were hired a few years ago to design an alpha paging system. We're finding a number of public safety agencies are moving into alpha paging. Sometimes they try commercial carriers. Of course, commercial carrier paging market's gotten really deteriorated in the coverage. And with some places going to P25, in this particular case, this was in Utah, there's a statewide 800 megahertz P25 system. So as users move on to that, then they're no longer doing tone and voice paging over, at least not on the same system they're doing their voice communications. So they've been converting to simulcast or alpha paging, and of course, typically we do those with simulcast. We've kind of come up with a kind of a standard approach depending on what the transport is. In this particular case, we've used sonic transmitters quite often and found them to be pretty reliable. Spectracom GPS and the old Zetron DAP 640 terminals, old standby. It's basically the same product they've had for like 400 years. In this case, we had mixed multiplex and transport, but at least it was all stable, so we used the convex ADL CTU. So this project actually, it's a fairly simple design, went together okay. We taught the technicians, it was going to be installed by the St. George technicians, and so we delivered it, or they bought all the equipment, and then we trained them on how to put it together, gave them all the drawings, all the block and level diagrams, all that engineering stuff. And then they went away for about 18 months, and we got a call from our client, and they said, the guys out in St. George are all upset, this was paid for with grant money, blah, blah, blah. And they're talking about taking it out. So I said, wow, man, this isn't that difficult. So I went down there, and the paging was horrible. It was work sometimes, not work other times. They could put 2 or 3 pagers out on a desk, and some would work, and some wouldn't work. So my first thought was, of course, it couldn't be the infrastructure design, right? So we started testing pagers, because that was my first thought. Okay, you got bad pagers. And when you listen to it, it would sound okay, kind of. And when you looked at it kind of on a service monitor, we just did a couple quick checks, kind of looked okay, so it wasn't anything really obvious. So I said, okay, so after the first day, we got to quit the shotgunning, let's start the routine right troubleshooting. Well, the first thing we found out was one of the transmitters in a remote area was only transmitting zeros instead of ones. So that created a little bit of kind of like a giant black hole in the middle of their coverage area. And so I said, well, where's your test receiver so we can take a look at what the modulation looks like from each one of the transmitters. Well, they hadn't installed a test receiver. They had done no real adjustment, no real checks on the simulcast delay. So they really had no idea what was going on. So we used a service monitor to find that one transmitter. But still, so we fixed that problem, and then we started listening to it again. Still, the problem is, did you guys set the levels? Nobody could remember if they ever actually set the levels. So we went down to the paging terminal, and the output of the paging terminal was +3. And so, with the modem tones coming out, of course, it kind of looks okay, but that modem technology uses zero crossing phase shift, and the modem tones are just being clipped horribly by the microwave channel banks, and so that didn't work. So we dropped the levels down to -10, and all of a sudden the paging started working. So that was a big part of it. So it's all about details, right? Details. It's like you can't just, the old 1, 2, 3, 4 test doesn't work anymore. The other thing was they were complaining about coverage. Well, they had moved 2 of the sites and to another county. And of course, there was a minor issue of licensing and a few things like that. But so we said, well, you're not going to get the right coverage in the county that it was designed for when you took 2 of the base stations and moved them to another county. So it was one of these things where, the process, was really a straightforward solution. It was just details, and nobody was really paying attention to the whole system piece. So that's really the lessons learned on this one. It's really nothing new, but I get a lot of calls from people about this kind of a problem. The first thing I always ask is, okay, what did you do with the levels? Did you set the levels? What are the levels set at? Go through that whole process with them, and it's amazing how many times I find that people haven't gone through that process. The other thing is, I just got a call from somebody not too long ago about using Quantars. We've used a lot of Quantars. They're a good base station. But when you buy a single Quantar and you can use it in simulcast, you have to do the factory mod comp adjustment. And there are a million. Motorola doesn't. They do this with a lot of products actually, which drives me nuts. But they don't align a lot of things with the factory. P25 radios, you can almost guarantee if you buy a P25 mobile unit. I don't know about other vendors, but I know because I've run into this with Motorola. If you buy P25 radios, you get them delivered to the field. You better run them through your Aeroflex and have them do an alignment. We have found consistently that the radios are not aligned from the factory. And Motorola does not align mod comp adjustments unless it's a simulcast adjustment. If you just buy a standard Quantar, which you can't buy anymore, but if you have them around, you've got to do the mod comp adjustment. Your PL won't sound right. You'll just have problems with it. There's a specific procedure in the manual to do it, and you have to follow that specific procedure to do it. So, anyway, again, details. Okay, so here's a project that we worked on. This is a project we did this year. The first version of this years ago, we used the Zetron, I can't remember the model number now, but they had those little delay boxes they used for paging that went into a Model 66. So we originally did this system. It provides coverage along the Columbia River. It's used for oil spill tactical response, and we put it in the mid-90s originally, and we just went through a big upgrade with that system, and the actual installation of that went really well. It's all KTV 8100 base stations. We really like that product. It's got a great price point. We found it extremely reliable. We've got some clients that have 150, 160 of them installed in some systems that have been in place for 4 or 5 years, and they have 2 or 3 failures maybe out of that whole time. So, they're very, very programmable, and you can get, if you only need 50 watts, you can get 2 base stations in 1 rack assembly. So it's a fairly compact unit. Anyway, so this project went along pretty well actually, and that one's installed. One of the things we started doing is we started using the last few projects DPS alarms. There's several other manufacturers around, but the nice part with that is trying to convince our clients that you really need an alarm system at the sites. It makes activity, monitoring, troubleshooting, a lot easier. This is a client for which we're actually managing their system, and so being able to just dial in remotely, from a laptop and read the conditions and all the base stations and do all that kind of stuff makes managing the system a lot easier. So here's an example of it. There's a great, I'd show our, that was the combiner system we designed in 1995. So obviously breadboarded, you can see there. We're having to replace that because one of the things that's happened when we installed that in 1995, we specifically chose sites, we built new sites, but that were located away from other radio sites because this system supports marine channels, and the marine channels, they're all carrier squelch. So there's no PL, so there's no protection from interference. So we had to stay away from the sites. Well, the Oregon Department of Transportation, for their new system, built their sites immediately adjacent to these two sites, and now we've all of a sudden gotten a lot of interference. So, so this is all being redesigned with crystal filters and whatnot, but like that great little picture. But this is what, I mean, we went from several MSF 5000s and a bunch of MSR 2000s. This was done as a narrowband upgrade into the tapes, and so this system, and they just look a lot simpler than they used to. So it's 48 volt DC power and the tape stations, alarm system. This project actually went pretty well. We didn't have too many lessons learned on this one. So the other thing we did, this one uses the Telex Vega. I don't know if they use it Vega anymore, but the Telex consoles. And one of the things, again, this is a system that we're providing system management on. And for troubleshooting, before we decide whether to call out a service shop or not, we can, from a laptop and virtually anywhere we are, pull up, dial it, basically access their system remotely over a remote VPN connection and run tests and listen to the audio and do all that kind of stuff. So it's a pretty cool way to do that. If you do that, plan ahead and get your system so you can remotely manage it and operate it. It's a lot easier to pull it up on a laptop and look at it before you send somebody out. I mean, some of these sites, even from the radio shop, are going to be a 2.5 hour drive just to get out to the site. So it's a lot easier to do that. We have had a little problem with the client's IP network. Their IT people occasionally forget that the radio system is on there, and they'll change something in the router, and then all of a sudden something stops working on the radio system. So that's a little bit of a problem. So we get a panic call. The first thing we do is call the IT guy and say, okay, so what do you guys been messing around with? All of the alarms are reported by email, and so that's the other thing. Occasionally the email stuff goes away because they did something with the email server. So here's a project. This one we are just in the process of deploying right at the moment. This is a rural county. I agree with Steve that I think there's going to be a lot of potential for simulcast in rural areas. One of the problems you go P25, even if you stay conventional, is you can't do paging on P25. There's no P25 pager. So
there's one out on the floor now.
Oh, is there somebody have one out on the floor now? So I would imagine it's still fairly expensive though, because the cost of one of the limiting factors in reducing the cost in P25 is the AMD vocoder intellectual property cost.
I got a price on it yesterday.
So
preliminary, 900.
yeah, so there you go. So because somebody told me a long time ago that the vocoder cost is about $400 in every radio as opposed to the AMD vocoder. So that really limits. I mean, so you're not going to get the $200 Chinois whatever 42 band radio like you can see out on the floor now in P25 just because of the vocoder cost. Anyway, so this system is a pretty broad, widespread system. We're in the process of, our intent was to have this system done probably a year ago, but we weren't in charge of doing the site development or actually managing that part of the project. And so the sites were just kind of recently completed. So we're just now getting this in. You can see we have 960 links and kind of a loop protected microwave. Columbia River Gorge runs right along here, so we've got these sites down here are actually in Oregon. They look back across the river. It's a very difficult terrain to manage. So this was TB, well actually it should be 8100 and 9100 typo there. So this is a fairly standard approach. We've done several systems using this approach, and it has become a fairly reliable way of implementing Simulcast. So one of the things is staging. We've talked about this before. Staging is really critical. In this particular case, again, there have been sort of several fits and starts on this project because of the site availability. So in this case, we're actually staging these in the basement of their new 911 center. You see, this is actually the prime site here. This has been installed. The prime site is also one of the RF sites. So you can see there's a large number of base stations in there. And then these are different racks. So right now we have all of the different sites are basically set up in the basement of their new 911 center, and the equipment's being installed. My guess is probably a week or so we'll actually have installation guys come out and install these out, haul them out to the sites and install them at the sites. So this way we can check everything, get all the levels set, make sure everything's aligned before we haul them out to the sites. Because some of those areas, this is a very large county. It takes about at least 2 hours to drive from one side of the county to the other, and even longer to get to some of the sites because there's no, it's a gravel road. You get to the edge of the road, and then it's a 45-minute drive on a gravel road after the mountain. Right now, some of the sites aren't even accessible, so I don't know, because of snow. So anyway, you can see there's quite a few channels. We have a lot of combiners. We've really tried to push with our clients by using combiners. They always kind of croak at the cost though, because a combiner like this can run $30,000 or $40,000 or more, and their idea is, well, why can't we just put more antennas on the tower? And so you try to talk to them about that. Sometimes they don't. Sometimes they buy it, sometimes they don't. So on this project is lesson learned. It always takes longer than you anticipate, especially when you can't control much of the implementation of the project. And the split project responsibility was really a problem on this one. You know that old saying, you see it on a car shop, a car repair shop, right? What's your hourly rate? It's $80 an hour, for the car repair time. It's $100 an hour if you watch. It's $125 an hour if you help. So, this is one of those that we should have raised our rates on it for this one, just because of the pain and suffering. Because again, the sites, we weren't responsible for the sites and the DC power and all that, and we've had to go back in and have a bunch of that stuff fixed because the people that did it really didn't know what they were doing. The other problem was the county was responsible for ordering. We gave them this huge spreadsheet with all this stuff on it to order, and it was like they randomly picked stuff off of it to order. For example, one of the big issues we ran into was rack screws. It seems like a minor thing, right? But you can't always just get the right kind of looking rack screw, right? And you run out of rack screws, and you got to stop, installing equipment. It doesn't look too good to have all tie wrapped into a rack. I've seen it. Anyway, so just little things like that were really a big impediment on this project. So this was a big issue for that. And the other problem was we had originally we were one of the things we found a lot is we sort of do this sort of system integration work where we don't really want to be a radio shop. I mean, that's not our business model. We're consultants and we do system integration work. And we do a lot of system commissioning, and so we're consultants with test equipment, so we know how to use it, that kind of stuff. But one of the problems we really found, at least out in our areas that we do a lot of work in, is the lack of radio shops. In our area, there's one main radio shop. It's a Motorola shop that covers most of those states. And depending on which individual shop you get, you may or may not get good results of that, depending on But if you're, and so that's okay to buy Motorola, but if you're not buying Motorola product and you want to get stuff installed, it's sometimes it's hard, particularly in the rural areas, to find somebody to do the installation work. That really gets to be a problem. So what's happened sometimes is we sort of get drug into doing some of the installation work. And this was a project that kind of started off that way. The hard part, though, is it's difficult to manage the project and do the work at the same time, because you're always sort of split between, you know, handling phone calls to get parts and punching down wires on a punch-down block. So we've tried to stay out of that, but, you know, if you get into that business, and you know, it makes it more difficult. And we're hoping this one will be online in 2 months. We've got our fingers crossed there to see if it'll be online. So right now, they went same thing. They went to narrowband and you know, reduction in coverage, and they had poor coverage to start off with. So this should be a huge improvement. But the issue for these guys is going to be who's going to maintain it. And they've tried to talk us into maintaining it. But again, we're not a radio shop. We don't want to be in that business. And so that's a problem. Because even if we use the nearest Motorola shop, you know, large enough shop anyway, they're probably an hour and a half drive to the county. So it gets to be a problem. So if any of you want to start opening shops in Eastern Washington or Oregon, there's some opportunity. So that's sort of the end of my presentation. You know, just some lessons learned. Anybody have any questions about any of the projects?
Have you ever used TV 9100s?
We have. The problem is you can't simulcast TV 9100s. I mean, not analog simulcast. So one of the problems you have is if you have TV 9100s out there because somebody bought them up with grant money and they're using an analog mode, and they bought them with grant money because they had to buy B25 capable radios, you have to replace the reciters in them to basically put them back as TV 8100s if you're going to do analog sound. So that's kind of a pain. So if you start out with buying, you know, start out with simulcast, then you start with 8100s.
Thank you, Joe.